Today's video deals more with balancing chemical equations. In this video, what I'm going to do is I'm just going to, these examples are not in your notes, so if you'd like to just write these down on a separate piece of paper or just kind of follow along with what I'm doing here. What I'm going to do in these examples, I'm going to write out the chemical formulas, and then we're going to balance the equations as well. So I'm not going to necessarily ask you to do this on a test, but it is something that you should be familiar with and be able to write. So when we do this, one of the things that we want to talk about first is some elements, anytime they're by themselves, always appear as a pair or in a group of two. Okay, for example, oxygen gas, if you remember back from chemistry 1, oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. And because we have these two unpaired electrons here, that makes oxygen very, very reactive. So what happens is, anytime oxygen is in nature, if there's another oxygen atom around, well, these two electrons will form a bond, and those two electrons will form a bond. And so oxygen in nature is always O2. Whenever an oxygen atom is by itself, it will simply react with whatever it hits next to form a compound. So oxygen, whenever it's by itself, such as right here, oxygen gas is never O, it's always O2. And there's a few elements that are like that. There's actually more than a few. There's 7 of them, okay? And the easy way to remember them is to kind of jam them all together. So we've got bromine, Br, iodine, nitrogen, chlorine, and then hydrogen, oxygen, and fluorine, okay? All of those 7 are what are called diatomic molecules. And again, what does that mean? Di means 2. And atomic just means atom. So they're 2 atom molecules. So anytime bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, or fluorine are by themselves, it will always appear as Br2, I2, N2, Cl2, H2, O2, and F2. So here on number 1, where it says solid aluminum, we write Al. And again, if we want to, we can put that S afterwards, which stands for solid, reacts with, so plus, oxygen gas, so here it is right there, O2 gas, to produce solid aluminum oxide. Now, here's why I'm not going to test you on this, but again, you should be familiar with it. I know that some of that naming stuff from Chemistry 1 is still a little bit challenging. So I just want to practice this a little bit more with you. So aluminum oxide is Al is +3, oxygen is -2. That means the formula is going to be Al2O3 after we switch those two, and that is a solid. Okay, now that's the only time I'm going to put the solids and the gases and the liquids and stuff in there. But now we do need to balance it. So I count 1 aluminum on the left, 2 on the right. So I'm going to put a 2 on that aluminum and in the reactant side. And then we've got 2 oxygens and 3 oxygens. So again, we've got a problem here where 3 doesn't become 2 or 2 doesn't become 3. So we have to go to 6. So we're going to put a 3 right there and put a 2 right there. And again, that 2 goes to here, and it also goes to here. So that makes 6 oxygens on the right-hand side. But that also messes up the aluminums, so we put a 4 right there, and that is now a balanced equation. Okay, I'm going to move a little bit quicker here on these next ones. Iron 3 oxide is Fe2O3. And guys, at any point, if you want to pause this and try to do it yourself, by all means, go right ahead. Okay, and carbon monoxide is CO, or after I write it out, if you want to pause it and just try to balance it, that's really what I want you to focus on here. Okay, yields, to yield means produces, solid iron, so that's just Fe, and carbon dioxide gas, so that's CO2. So 2 irons, 4 oxygens, right? 3 plus 1 is 4. So we need a 2 right there. But that also now makes 2 carbons. So I need a 2 right there. Uh-oh, this is getting a little bit tricky here, isn't it? Okay. Then this is what you got to do. You got to keep going back and forth. Now we have 5 oxygens, right? 5 all total on the left-hand side. So the only thing I can do is bump that number up again to a 3. But now that messes up my carbons, so I got to go back and put a 3 right there, and I believe we are now balanced. 2 irons, 2 irons, 6 oxygens, 6 oxygens, 3 carbons, 3 carbons. Okay, hey, Mr. Johnson, what happens, though, if when we do this, it never, ever balances? Then you made a mistake. There's something written wrong in your equation. They will always, always balance. Okay, number 3, zinc metal is just Zn. Reacts with aqueous silver chloride. Silver chloride is AgCl. Silver's +1, chlorine's -1. They cancel each other out. To produce zinc chloride, zinc's +2. So we need ZnCl2 and silver metal. So a 2 right there. Or sorry, an Ag right there. So the only thing that's not balanced are the chlorines. So I'm going to put a 2 right there. And I'm going to put a 2 right there. And now it is balanced. Okay, number 4, solid ammonium nitrate. Ammonium is NH4+. Nitrate is NO3-. It decomposes to form dinitrogen monoxide. So dinitrogen monoxide and water, H2O. So even though they're separate, there are 2 N's on the left-hand side, 2 N's on the right-hand side, 4 H's on the left-hand side. So I need to put a 2 right there to make 4 H's. And then 3 oxygens on the left. And all total, we've got 1 plus 2 more, 3 oxygens on the right. That equation is balanced. Okay, number 5, solid aluminum is just Al with aqueous sulfuric acid. That's H2SO4. And I think that's the first one we saw that. Remember, when it's aqueous, that just means it's dissolved in water. You will see that AQ afterwards as well. To produce some liquid aluminum sulfate. So aluminum, again, just a refresher here, aluminum's +3. Sulfate is -2. So that's going to be Al2SO4 And, hydrogen gas. Remember, this is a hard one to remember. But remember, if you put them all together, what does that spell? It spells Brinkelhoff. Hoff is that H is in there. That's hydrogen. Anytime hydrogen's by itself, it's always H2. So, a couple things right away. We've got 2 aluminums on the right-hand side, so we need 2 aluminums on the left-hand side. And remember that we have SO4 here and we have SO4 here. So just keep them together. We have 1 SO4 on the left-hand side and 3 over here. So we need to put a 3 right there, and that balances out the sulfates. And then that makes 6 hydrogens, so we need 6 hydrogens. And now that is balanced. Okay, number 6, carbon tetrahydride would be CH4, more commonly known as methane. Okay, reacts again with oxygen gas. It's a Brinkelhoff. It's a diatomic molecule, so it's O2. Producing carbon dioxide, CO2, and water, H2O. So to balance this one, 1 carbon, 4 hydrogens. So I put a 2 right there. That makes 4 hydrogens. And then all total on the right-hand side, we have 4 oxygen atoms. And so we put a 2 right there. And that is now balanced. So overall, we've got 1 methane, 1 carbon tetrahydride, 2 oxygens, 1 CO2, and 2 waters. Okay, number 7. There's 10 all total, if you're wondering, hey, when's this over? Okay, number 7 says a solution of acetic acid, that comes from acetate. So that's C2H3O2. And a solution of magnesium hydroxide, MgOH2, producing water, H2O, and magnesium acetate. Okay? And so now, let's see, we've got 2 acetates here, so we need a 2 right here. That makes 4 hydrogens all total, so we need a 2 right there, and that equation is now balanced. Okay, for these last 3, if you haven't done it yet, after I write out the equation, go ahead and pause it and make sure you can balance these by yourself. So number 8, nitrogen gas. So that is another one. That's Brinkel. That N is Brinkelhoff. So nitrogen by itself, that's got to be 2 of them, is bubbled into lithium metal, producing lithium nitride. So lithium's +1, nitrogen's -3. So it's just Li3N. Okay, so go ahead and pause it now. Let me go out and rate. I'll rate all of them out. So propane C3H8 in a barbecue reacts with O2, releasing a large amount of heat. Heat is not a chemical, so you don't include it in the chemical equation. And it produces carbon dioxide and water vapor. And then our last one, Na3PO4, is sodium phosphate. And it's going to react with Fe2SO4 and it's going to make sodium sulfate, Na2SO4, and iron 3 phosphate, which is not Fe3, just FePO4. Okay, so go ahead and pause it at this point and make sure that you can balance all 3 of those. I'm going to go back to number 8 now. So right away I see 2 nitrogens. Here I only see 1, so I'm going to put a 2 right there. That makes 6 lithiums, so I'm going to put a 6 right there, and that's all you need for number 8. Okay, for number 9, 3 carbons. 3 carbons. 8 hydrogens on the left-hand side. 8 hydrogens on the right-hand side. And then all total, be careful here, because 3 times 2 is 6, plus another 4 is 10. So that's 10 oxygen atoms, so we need a 5 right there, because 5 times 2 is 10. Okay, and that equation is now balanced. And again, what does that mean? It means that as you release that propane into your barbecue and you light that match, it reacts with the oxygen atoms that are already in the air. It releases a large amount of heat, which is the part that we care about. But then chemically, what does it make it? It makes 3 molecules of carbon dioxide and 4 molecules of water. Okay, our last one, right away, 3 sodiums, 2 sodiums. We got to go to 6. So 2 and 3. And then we have 2 phosphates. Here we only have 1 phosphate. Remember, if they stay together, make it easier on yourself. So I'm going to put a 2 right there. We have 2 irons, 3 sulfates, 3 sulfates. That equation is now balanced. Okay, so sometimes it looks like a big complicated equation, but look at all we needed. We had to put a 2, a 3, and a 2 right there to balance that equation. Okay, let me do one more that's somewhat similar to this. C4H10 plus O2 making CO2 and H2O. So really, really similar, but we've got 4 carbons. Sorry, that CO2 is terrible. CO2. So 4 carbons. So I'm going to put a 4 right there. 10 hydrogens. Means I got to put a 5 right there. But then again, we've got this problem. 4 times 2 is 8, plus 5, that's 13 oxygen atoms. On this side, we have an odd number. On the right-hand side, we have an odd number. On the left-hand side, we have an even number. And we need to make them the same. So, in order to do that, you've got a couple of options. You could technically say, even though it would not be correct, you need 13 oxygens. Well, 6.5 is 13, right? So you could say 13 halves O2, which technically would equal 13, right? The better way to do that, and what I'm going to want you to do, is you start back at the very beginning and you double that initial amount, which means now we have to double this and we have to double this. So now we have 16 plus 10. Now we have 26 oxygens, which means now we can have 13 O2s, and that equation is now balanced.